am going to click this. Right. So Etap, this is the Etap software which is available here. So now, first of all, I am going to tell what are the uses of Etap, electrical transient analysis program. So in most of the electrical consulting companies, they are utilizing this software. Based on this software analysis report, they are going to design the or sizing the cable size and how the conductors for the transmission line, the size which may be going to choose. And another one big advantage of this software is that is the directional power flow of the system, right? So this is the software which is available. This is version of 16, but in already you are seeing that is the Etap at the 2020 year, which is available in the network, right? So now I am going to start one new file. I am clicking. So these are all the different thing. So I am also randomly giving some name. Test 1. So this is the root path of your file, which is C drive, Etap folder 1600, and I am in my file name, right? If you want to change, again the change. Then if you suppose if you are used in the local SQL, there is no problem. Suppose if you are installed in your license key in your college based central server based, you may going to select properly this. Otherwise, it may you may going to take some other difficulties during the simulation, run the simulation. Now I am going to give that OK. So this is a username. This is my username of that the software, right? So now it can be created. Yes, it is totally created now, right? That is the different ways of available software which is available here. So this is that. First of all, we are going to draw one single line diagram and run the power flow analysis randomly for today's session. So next day, which means tomorrow, we are going to run the samples or the problem which is available in the standard power system book, right? Any other standard power system book, I am also going to take that book. So what information available, that same problem I am also going to solve by using the Etap software. So today we are going to simple how to draw the SLD. So as per our workshop, that is we are going to cover the content of the drawing of a SLDs and the load flow analysis in today's session. So for that purpose, we are going to first draw the SLD. So SLD means single line diagram. So this is the basic three bus system. I am going to draw it. So this is the bus which is available in the Etap. I am also going to click in my mouse in the right click. So please see, if I want to rotate this bus from horizontal to vertical, you may going to see now it may be seen as a black color. Please see, are you able to see this color? Black color. Hello?
Yes, sir, we can see the color.
Yes, this is that the black color. So whenever I am going to touch this, it may be converted into that the color which may be going to change in the other color. So this red color is not the exactly standard. If you want to change this animation colors, you may going to change in the setting. So the color will be changed. Next, if I want to rotate this, I am also going to press Ctrl R in my keyboard. Please note down that is the key button is Ctrl R, Control key and R key. This is the one way, and another one way is you may going to press this, and then you may going to take as a right click. This is the rotate option which is available, plus 90 or minus 90 or 180 degree. That is the reverse polarity. Depends upon the which type of module we are used. Based on that module we are going to identify. Now I want to drag this bus. So how this is the small arrow which can be visualized now. Now I am going to drag this, right? So whenever this small arrow which can be highlighted, during that time I am going to left left click of my mouse and then drag it. Okay. So this is the bus one. Next I am also going to select that another bus. So I want to rotate this bus. Again, Control R I am pressing. So this is a Control R. So I am also going to drag this. I am drag this. So this is that what is that the bus 2. Next we are going to take as that the bus 3. So simple bus 3. So this is the bus 3 which is available as like this. Now I want to connect these 3 buses by using the transmission line. So before the connecting this bus, I am definitely we want to connect the source, right? So we are going to connect the source. That is, this is the power grid. So we are going to do in this power grid operation at the time of relay operation. Now that is the one of the source is the generator source. So I am also going to drag and drop here. Next I am going to rotate, right? So this is I am also going to rotate and I am going to connect this yes. So again rotate, which this is the small box is highlighted. Again drag, left click and drag. Whenever I am going to touch this bus, the color is changed as black color to pink color. During that time you may drop this, right? Now the system which can be connected, right? So next we want to connect these 2 buses. Before giving this value, so I am also going to give the rating. So what is the rating of that system? This is assume I am also giving randomly say 10 megawatt. So bus kilo voltage is 11 kilowatt. So 11 kV 10 megawatt for the 85% of power factor. The var value is automatically I am also going to something exchange 87. So the automatically the VA rating is calculated and everything, all the values which can be calculated, right? So and if you need that the capacity, that is the curve drawing impedance model. So during that the simulation, how I am going to give the impedance model based on the equivalent, we are giving the typical data. So I am also during the running time, this data which may be required by the bus. So during that time I am going to fix. Okay, right. Now I am also giving the OK. Right. At the same time, this bus is assumed as a swing bus for power flow analysis. Next, another one source I am also going to connect in the another bus. This is the another source which is available here. Again, I am also going to connect in buses to bus 2. So this is that the value rating the kVA is the same kVA. So this is assumed as that is what I am says, that is 25 megawatt. This is 93% of that the power factor. So this is the overall system which can be given. Then okay, right? Now I want to connect these 3 buses by using the transmission line. So this is the transmission line which is available here. So I am also going to press this transmission line. So I want to rotate, that is the control, placed it, again highlight it. So I'm going to now press the control R. So this control R which can be rotated. So I'm going to move this mouse point near the module. It may highlighted the pink color red box. This line which can be dragged and then connected to that to the bus 1. Similarly, I am also going to connect it in the bus 2. Okay. So now we want to give that the what I am saying, the transmission line parameter. Assume this line is 7 kilometer for 7 kilometer or mile. So I am assumed as a kilometer. So that is the parameters, the impedance value I am going to given. So assume that is the impedance value is user defined. So in the user defined 0.12, again 0.12, x value is 0.2. Again we are going to 0.002. This value we are given, right? So again we are going to give that the okay, right? So similarly, I am going to drag the another transmission model here, drag and drop. Next I am going to connect this. Please see what is this, the parameter 0 value, what is that the other value, impedance, everything it is not visualized. Next I am going to connect this. This you may going to see the bus value is 0 now. Now I am going to connect this. Now the automatically the bus value is 11 kV changes. Please note down. So before connecting it is 11 kV, 0 kV. So after I am connecting this bus, it may be converted automatically in the 11 kV. Next I am going to double click this transmission line parameters. So different way of feeding that impedance which is available. So one by one we are going to see, that is we are going to give that the user defined model. So kilometer is assumed, this is a 12 kilometer line, this is a kilometer. So if you need, then give that the tolerance and the x value. This is 0.12. Again this is also 0.122. Again this is a 0.2. Again this is a 0.002. So I am also giving the what is R and X value of the transmission line. Again I am also giving the signal of that okay, right? So the next step, what is that? The next step, how we are going to do it. So this is the next step, the another transmission line which is I am going to taken here. So this is which may be connected into that the bus. So again I am also going to connect it in this bus. We are going to feed that the line, that is the parameters information. So this is assumed as a 25 kilometer line, kilometer, right? it's a kilometer. Then the impedance is a user defined. So the user defined already all are the same conductor 0.12 again that is 0.122 this is that 0.2 again this value is 0.002. So this is the basic operations we are already given that the system. So this is the basic thing of that the SLD single line diagram. So again we are going to feed the transformer and then change the voltage also. So how we are going to change the transformers and the voltages and everything we are going to see one by one, because when I am going to connect all the modules in the single at the time of first attempt, you may make some other confusion with the that is drawing and how we are going to plot that everything, right? So this is the voltage, this is the swing machine, swing bus swing machine. Again here we are going to given as voltage control, right? 25 megawatt, it's a voltage control bus. Again we are going to connect the load, that is the lumped load parameter. So what is the load here we are going to connect that. You may going to see, so one is 25 megawatt, another one is that the 10 megawatt. So that in that the nameplate, that is the rated kV 11 kV automatically selected. Now I am going to select that is 21 MVA. So if you are selecting MVA, megawatt, megawatt and the 0.85% of that the power factor. So now I am going to slightly adjust that is the 89.97. So it may be automatically calculated. The everything automatically calculated. So I am also going to explain how the MVR value, breaking value, everything will be changed, or how the calculated and the conventional system and the short circuit dynamic modeling, time domain analysis. We are going to see one by one, right? Okay. So this is the load parameter we are going to connect. So now our SLD single line diagram is ready for load flow analysis only. It's ready for the load flow analysis only, but we are going to give some other data also. So what data is required during the error arising during the simulation, how it can be solved, we will see one by one, right? So next, if you want, that is the number of power system simulations we are able to run this software. So this is that the load flow analysis, again the short circuit analysis, arc flashing. If we are used in the CB based system, how arc flashing is occur. Next one is motor acceleration. So we are going to see how that the motor which can be accelerated in the next class. Next, the harmonic loads. So transient stability analysis if the fault is connected, and then in the configuration parameter we are going to set the fault and everything. So next one is the DC load flow is analysis, DC short circuit, arc flash, battery discharging and size. So this is the very important. This may be going to reflect your EV, electrical vehicle. Definitely the last session I am going to do by using this battery discharging and sizing. Based on this battery charging and discharging effect, the oscillation control also will also going to control. Next one is unbalanced power flow. So actually the current trend is only in the unbalanced power flow, because all the residential loads are definitely single phase. Maximum in India, more than 85% all the residential load other than metropolitan cities are that is what type of load, that is the single phase based load. So definitely we are facing the load unbalancing problem. Only unbalanced load flow is running in the all the SLDC, that is load dispatch centers, right? So that is the another one thing. Next one is the time domain load flow. So switch the current penetration to the time domain analysis. This is something else switching function added during the time how the load flow is occur. So this is short circuit analysis. We are going to add the short circuit which bus for what time, everything we are going to consider. This is continuation based load flow analysis. So the PV curve, we are obtained the notch point of that the PV. So next, optimal power flow, reliability assessment, the optimal capacitor. We are going to place that the capacitor and how the capacitor which can be used. Next, switching optimizations short, that is the switch the current presentation in the FMSR. So in the different cases. So these are all the thing. And another one is very important is rail traction power. So all this effect which can be incorporated in the new version of the Etap. The older version definitely this battery discharging and sizing, and that is the nodal point, that is a contingency analysis based system FMSR, and the rail traction effect is not included. But this version is so very much nice operation. We are able to do it for the load flow analysis. So first here we are going to consider the load flow. See, please see, this is edit mode. These are all the simulating mode, right? So whenever you are going to press this pencil based symbol, the window, the window will be work in the what type of mode, which is available in the edit mode. Now I am going to that the power flow mode. In the power flow mode, this is the run the load flow analysis. Load flow analysis which can be run in this diagram. Next one is that the auto run flow on and off disabled or enabled based on that switching if it is available. But this circuit we have not fixed any switching modules. Yes, anybody?
Sir, sir.
Yes.
இல்ல இது டிஸ்ப்ளே வரலன்னு சொல்லிட்டு இருந்த ஃபோன் பண்ணாங்க அத ஓகே ஓகே
தெரியுதா சார் டிஸ்ப்ளே
இப்போ ஓகே சார் ஓகே ஓகே
Can I continue? Hello.
Yes sir.
Yes. Now I am going to select the topic of that, that is the real and reactive power based load flow analysis. So I am also going to give the name of TES, test LOAD, load flow. Okay, so some other name, that is I am also going to fix. Again I am also going to fix that. So that is that the invalid user defined positives can of RT1, RT2 same for that the temperature T1 and T2. So we need the proper information for the line 2 and line 3. So this is line 2 and line 3. So in the line 1 already we are giving that the data that is in the impedance, right? So in the T1 and the T2 which is we have given, then okay, this is for line 3. So this is line 1 parameter impedance. So different 1 and 2.2 and 0.3 different impedance values we have going to be taken. Only the parameters. Used values. This is mile, this is in the kilometer.
Hello, sir.
Yes.
Sir, what about zero sequence and negative sequence component?
Yes. During that fault time, if we are going to run the short circuit analysis, during that time we need the positive, negative, and zero sequence analysis, right? Hello.
Yes, sir.
Yes, during the short circuit analysis time, that is positive, negative, and zero sequence analysis, zero sequence process. That is we need for the fault current calculations. So subsequent classes, I am going to take with this positive, negative, and this zero sequence. Okay.
Okay. And sir, second thing,
Yes.
these values are per unit value or actual value?
These values.
Yeah.
Actually, please wait. Actually, we are going to, yes, I have completed this first. After completing this, I am also how the real conductor value is added this device. Okay, I will tell you. So I will tell you. Okay, so how the real conductor R, X, and the different temperature values which can be incorporated in this transmission line. So how we are going to implement it. So that is the information is available in the blog. Suppose if I am going to select again, I want to re-enter. Okay, if you are asking for that purpose, I am also going to select, right? So this is that the basic things, the different types of conductors which is available in the market. Okay, suppose if you are choosing transmission distribution book, so that is the different way and sizing, and based on our TATC values, transmission values which is available. This is 1 mile or total length, all size. If you are going to select all are available na available size, we are going to take. So English or that is metric, we are going to metric. If we are going to select the English during the starting time, you may give the English type standard. If we are choose the metric during the time of file creation, you may give the metric. Otherwise, it may give the some problem, right? Again, based on this availability conductor standard, actual practical conductor in all the consultancy companies, they are going to select this wire, this part, or in the TND book, and then select. They are giving the okay, it will be loaded here, right? It will be similarly we are going to take as that ground wire. So the south wire or APRI, that is which is available. So based on that service, I am also going to take. So the entire data will be so which is available. Similarly, that is, these are all that each and every company they are going to upload on his conductor data in the file. As if you are doing in the PSpice simulation, each and IC are that is component manufacturer, they are going to form the PSpice or file developed for the simulation and then uploaded in the common network, common sourcing. Similarly, all the standard conductor manufacturers, they are developed on the conductor resistance reactance, every values they are going to develop and then loaded commonly. That data which can be inherited by the line. Okay. Now, are you understand? Hello? I think you are in online. Can I proceed?
Yes, sir. Yes.
I don't know whether it is available. So this is a user-defined kilometers and ohms which is available in the ohm. So the next thing we have going to consider 12 kilometers. That is that impedance, which is nothing given in the kilometer calculated value. If you are going to calculate, they are not going to consider. But we have going to given that
Excuse me,
user defined. Yes.
sir. Can you enlarge the Etap software, sir?
Enlarge.
Yes, sir. Maximize it, sir.
Please wait. Are you able to see now?
Can you maximize that full screen, sir, on the top right corner, sir? In right top corner, sir.
Here.
Top, sir. Maximize. The values are very small, sir, so that.
These values.
Yes, yes, sir. Now we can see it, sir.
Okay. So these font size are the standard. Okay, I will change the basic setting of that MATLAB. So because then only you can visualize, because this is the standard size of that MATLAB developers letter fonting. I think if you are not visualized, I am shrink this diagram and then enlarge it.
No, sir, it is visible only, sir. You can better maximize it on the top corner, sir. On top, sir.
Now?
Nearer to the close button, you can maximize it, sir. On top.
This button?
Header, sir.
Okay,
yes. No, in top, sir. Right corner, sir.
This
yes,
button?
Sir. No, sir. We are going to minimize and maximize Word document and all. We are having an option, right, sir?
No, madam. This is this type of option. It is not available in this version, latest version. Suppose if it is increase, I am also going to zoom
Yes,
as like this.
Oh, okay.
Now yes, you are able to see. Now you are, that the letter is visible, ma'am.
Yes, sir. Yes, sir.
Yes. Okay. Yes, I think now it is visualized. Okay, so now we are giving that the data, this is the rating of this is a 10 megawatt, 11, and the MVA rating which can be automatically calculated. So based on that requirement, so the capability, this is the load, that is the curve, that is the swing operation, how it can be. So this is that this is the fuel cost operation. We need that impedance model. So that is the equivalent based typical model we are loading, right? So typical loading, again that based on that our data and the circle line based diagram, the all the subtransient transient impedance we are going to calculate by the our requirement, right? So similarly, I am also going to change this operation. So here that is the impedance model. So equivalent circuit based typical model I am also loading. Again, okay, right? So similarly, this is the load, lumped load. I am that is which is we have going to reduce to 21 MVA, that is 18.2. That is also giving. So what is that? The total value is calculated. Again, run. So this is that the load flow is running. What is the maximum value we are going to feed? So this is the minus of the J action. We are going to feed that the load flow. So these are the data. I think this is not 100% visualized to you. So I am also going to generate that the report in the different way, one by one. So I am also first generate the report in the MS Word format in the complete option test load flow, right? Please wait. I am also going to write. This is that the load flow analysis, which is generally available. That is the what is the date 12/7/2021, and that is the different locations. So number of that the line or cable, 3 lines available. There is no reactor and transformer. Total the devices. So Newton Raphson method, maximum 19 nitration. That is that the frequency 60. So if you are going to metric, the frequency value is changes, right? So that is the transformer impedance. If it is no transformer, directly we are going to power flow analysis result. So the constant Z value, current value, what is the K value? Each bus having a same kVA. So what is the maximum swing bus? How much of the power which can be from that load, from source to load? This is the RX value. The temperature based RX value, how we are going to be obtained from that the different size from that the library. Suppose if you are using this library, the line conductor, that value is inherited here. Suppose, please see, but if the values is not exactly correct, the system cannot be converged. Please see that how the error will become. Now I am going to take a parameter conductor library and a wire library. So this is this method I am going to taken for that. Okay, so again the impedance is calculated, right? So calculated ohms, so it may given as a error, it may be given. So the sequency time, so I am also going to change this value, again run, right? So that is the load flow analysis. Now the load flow analysis is running. So again I am going to take an, that is that the complete report in the MS Word format. So load flow, that is the test 1. Again I am going to take. So this file I am going to close. This is complete MS Word. Yes, Word is opening. Yes. Now you may going to see that is I am also going to add some library values, that is the bus values. I am also going to take into account for this subsystems values based on that constant bus input data. We are going to add it. We are going to add the label resistance of that the specific what I am says, that is the specific R and A X values. So based on that values, the load flow analysis which can be given, that is what is the base and the revision. So what R, X, Y and Z, that is that impedance, which means bus impedance values. Again that is this is the load flow report. Megawatt, the bus 1, bus 2, bus 3. This is the load flow. Amps, that is the power factor, MVR rating, how much of the power which can be flow from that one thing to another thing. So this is the entire load flow report we are going to obtain from that. The next bus loading, how much of the bus is loaded. Only bus 3 is load is connected. So it's given by the 3 unit. So the one is 100%, another one is that the 95%. So this is the line flow. So how much of that? So suppose line 1 and line 2 and line 3. Please see, this is the negative symbol. You see this negative, which means it may be going to act as the reactive. That is the current effect is created. The voltage is changes. Voltage level is changes. So drop in the B magnitude. So that is we are going to from that the different level, that is 98 point. This is line 1 and line 2 having that the same 100% from 2 bus is 98%. That is line 2 is that 82. So we are going to see line 1 1 to 2. Line 1 means 1 to 2. How long kilometers? So I am going to click. So the kilometer line length is 7 kilometers. At the same time, line 2 is 12 kilometers. So here we are going to see the result. So 82.782 here, because if the line length is increased, again that is the voltage drop will be. Here the line length is higher value, the voltage drop will be increased. So this is the asset summary. What are the critical and marginal effect? So critical report under voltage and lower voltage, we are giving a random data. There is no that is that different analysis. Summary of the total generation, loading and demand, and what is that the power factor, everything which is available. So if you want the specific output for the AC and color values and the AC to DC we are going to obtain, we are going to select that the report for the specific output of our solutions. Output of that our solutions. Suppose I want to which means connect that the any other motor, how the motor which can be performed or which can be connected in the any other thing other than that. So these are all the result for that specific. I want to know the branch result. So we have going to obtain the branch again from 2. Both the things we have added. So rating 1 and 2. What is how much of the power fault we are going to KVA or MVA? So MVA is connected. If it is load, only one load is connected, but the branches is 3 branches which is available. Buses 3 buses which is available. So everything that the load is available. If you want to do this generator, this is the generator info, this bus result. If you want to export the report again, you have simply export the result for that in our analysis. So this is the simple way of find the load flow analysis of the Etap. Now I am going to add some other component of this unit. Again I am going to run the power flow. Run the power flow. How the power flow is changes from the old one. Now I am going to change this for the display purpose. So complete Y11. So this is not visualized otherwise. So simply that is in the negative and capacitive action. I am going to edit mode. So simply I am going to take in the edit mode. So simply I am going to take as another load. So this load is connected here, right? Connected to here. Simply I am also going to take this load as that is the 2 MVA, sorry. MVA. So at the percentage is very low percentage of 0.6 power factor. So during that time, how the system which can be response, This is something else, the new way. So now I am going to take as that my power flow, right? So that is I am going to run the power flow, right? So generate the report, that is complete report here. So before entering this point, please see this report. I am also going to take as load. So last time one row is available. Here there is the 2 row is available. That is 2000 kV or 2 MVA. So what is the kilowatt? It is very low power factor. For that purpose, we are going to obtain as like this. Next, branch results. How that the branch flow is changes. Next one is the buses result. These are all the generator info. Next one is the source info. This is that load. So here now we are going to how that the model is differ from the different power flow cadre, right? So that is 0.89, 0.97 lagging. This is the problem we are seeing. But in our old case is something else different. Old case is something else different. Please see. So I'm going to generate MS Word. Please wait. The report will be generated. Yes. One. This is 1 result. Test 1 result. MS Word. So I'm going to generate to the PDF. Yes. So I'm going to take as that the overall summary. Yes, please see that the overall summary of the total generation, loading and the demand section. I'm going to enlarge this. Yes. Yes, now it's available. So yes, please see that is the total motor and the static load of that 89.9 up to 9, which is available here. That is the lagging is occur because we are going to reduce our power factor. We are going to reduce the power factor for 6.5, the 86 and 87. And simultaneously VA are taking 0.948 and that is this is a huge much 5.057. The same thing, that is we are going to take as the load for here 0.68 and 3 point that